Sloths. Sloths take their time in just about every phase of their life. Obviously, it's well documented that they don't move very quickly when going up and down trees and high above in branches. That can put them at peril when they have to go down to the ground, but up above in the canopy they can stay there safely and hang out, literally. Movement isn't the only slow aspect of a sloth's life, though. Digestion is exceptionally slow, too. While the animal creeps along at a glacial pace through the forest, its digested food creeps equally slowly through its insides. For reference, the average human typically digests each meal in roughly 12 to 24 hours, with some people experiencing a full digestion cycle a bit longer than that. From there, excess waste is eliminated, and we move on. Sloths stretch that process out to interminable lengths, though. The average sloth takes more than 2 weeks to fully digest each meal. And scientists have found that in the most extreme, sloths can go through the digestion process for up to 30 days. The reason for that is evolutionary. For sloths, coming down from the treetops is a dangerous time. They would prefer to stay up high and away from predators, so their digestion slows to ensure they don't have to use the forest facilities very often. They can hold it in for a long, long time, basically. When they come down to relieve themselves, which is only about once a week on average, they can lose up to a third of their body weight. Then it's back up into the trees to hang out and process food slowly once more. Elephants. Elephants can't jump. They are too heavy, and their bodies are designed so that it's impossible for them to lift all 4 feet off the ground at once, even when they are stampeding. Consider their fastest run as some sort of version of speed walking then, but this isn't the animal fact that we're covering here. In fact, most facts you'll read out there across the internet claim elephants are the only mammals that can't jump, but that's simply not true. In reality, lots of mammals cannot jump. Also on that list of land-bound creatures are the rhino, the hippo, the sloth, and many more. The difference with them, however, is that both rhinos and hippos can get all 4 feet off the ground when running at top speed, unlike elephants. So, the next time you hear somebody try to claim elephants are unique in the mammal realm for their inability to hop, you can correct them with this actually true animal update instead. Ostrich. The ostrich is the world's biggest bird, and it also has some of the biggest eyes in the entire animal kingdom. In fact, the ostrich's eyes are so big that they are actually bigger than their brains. Each eye measures about 2 inches, or roughly 5 centimeters, in diameter on average. That's just about the size of a billiard ball you'd find in a pool hall. But for an ostrich, 2 of those things crammed into its tiny head make for some seriously powerful sight. When you think about it, maybe it's no wonder that the ostrich's eyes are bigger than its brain. There simply isn't any more room left to fit a brain inside that small dome. The reason ostriches have such large eyes and such comparatively small brains is, like anything, the result of a long evolutionary process. For the ostrich, powerful vision is critical to staying alive. With an unusually high number of photoreceptor cells within their eyeballs and some uniquely efficient processing power that sends images to those tiny brains, the ostrich can see predators clearly from very far away. And when it does, its other massive evolutionary adaptation comes in, its long, strong legs. As flightless birds, ostriches sprint instead of flying away upon seeing predators, crediting their eyes more than their brains for allowing them to live another day. Orangutans. We don't often think about it, but it makes perfect sense that animals would regularly break bones out in the wild. They run, jump, chase prey, scurry from predators, climb, and inevitably get injured. Depending on the animal in question, falls from trees and ledges or tumbles down hills and ravines can be frequent, if not common. So it's not particularly surprising to learn that a high proportion of wild animals suffer broken bones during their lifetimes. For some, it can spell a death sentence as predators descend on the wounded creature. For others, depending on the severity of the break, these bones can slowly and imperfectly heal, allowing the animal to live on into relatively old age. And for orangutans, these breaks are so common that researchers practically expect to see them in wild subjects they observe and study. According to some estimates, at least 50% of adult orangutans have one or several fractured bones somewhere in their body. These monkeys are agile, strong, and adept at swinging across tree branches and climbing through canopies. But that doesn't mean they are perfect. In fact, orangutans very often fall out of trees, and when they do, many suffer severe bone fractures when they hit the ground. The lucky ones are left relatively less scathed and can nurse the injury into a ton of scar tissue after weeks of pain. Giraffes. Giraffes have a larynx just like every other mammal on Earth, but they don't use it to make discernible noises. For decades, scientists have assumed that's because of their long, narrow tracheas and relatively small lung capacities. As the theory went, giraffes had the parts to talk, but simply couldn't produce vocal noises because it was too difficult on their infamously long necks. And since researchers spent thousands of hours around the beautiful beasts in zoos and the wild while never hearing them do more than snort through their nostrils, that was settled science, until 2015. That year, scientists announced that giraffes actually do talk in their own way, but instead of using airflow to vibrate their vocal cords like other animals and humans, they simply emit a high-frequency hum. The sound is similar in practice to what the giraffe's close relative, the okapi, produces, and it is far too low for humans to hear naturally. So, biologists had to set up special sound recording equipment in zoos and spend countless hours analyzing hundreds of hours of tapes. But the hum is there. Giraffes do communicate with each other. They just don't use their vocal cords and thus can't talk like the barks, roars, squeaks, and sounds of other mammals. Snails. Some people love to hit snooze and doze off for as long as their bodies will allow, especially on weekends while trying to catch up on rest. But whatever your answer about sleeping in may be, we can guarantee that snails have you beat. That's because snails don't just doze for hours on end, or days, or even months. Amazingly, they have been known to sleep for years at a time when the situation calls for it. Snails need moisture to thrive and survive. They'll often come out in the early mornings in many environments when dew is on the grass and plants. They'll leave their little trails and slither along, doing their thing in peace. But when the weather doesn't cooperate with that need for moisture, snails intuitively know when to shut it down. In dry and otherwise harsh conditions, snails shift into two different modes of hibernation. One is the normal wintertime sleep that other animals, like bears, are also famous for. The other is called estivation, which occurs during the summer and allows snails to sleep through the hottest, most uncomfortable months. But it's the timing that will really shock you. Under the right or wrong conditions, snails will shut down and hibernate for up to 3 years at a time. Penguin. As the story goes, 3% of Antarctica's ice supposedly is frozen penguin pee. The glaciers are in a really cold spot on Earth, of course, and when penguins pee on them, the temperature is so low that the urine can't evaporate like it would in a normal climate. Very quickly, the pee freezes up as part of the ice, and over time, the entire continent is just one big frozen block of ice pee. Like all other birds, penguins don't actually pee the way we recognize it in most other animals. They don't have a urethra or even a bladder, and instead of converting their waste into urea, penguins transition it to uric acid. Then, like other birds, penguins secrete that waste product simultaneously with their poop. The end result is that patented white-colored pasty bird dropping that we all know too well from one or many close encounters with pigeons. So, penguin pee does not account for 3% of Antarctica's ice shelf as many claim. And now you know why. That's all for today. Thanks for watching and see you next time.